Welcome to the stream. This will be stream number 3, I think, in this video of me creating a triple TMC5130 stepper driver that you can control with normal Python. So I've done some big changes over camera, mainly because it wasn't that important to show the changes being done, but would rather be smarter to just talk about it. At least that was my conclusion. So let's just start. So first of all, so I made like a new, let's remove this. So I made a new color profile just to make things look a bit nicer. I recorded a video with it. I actually had to do it 2 times, and I did it in different ways because I just wanted to see how long time it would take for me to just do like a quick stream about something else. And yeah, that's it. So first of all, what change did I do? Well, it's now not a triple driver anymore. So why would I do that? So thing is, this driver is going to be pre-assembled. And the components that you leave out of the design when you see kind of the most simple design versus the most advanced design, at least the pre-designs, which are already made. So let's just have a look at the Trinamic site again, and I'll explain. So yeah, this is the chip. Okay, so you have the TMC5130 Bob, and you have the TMC5130 eval. So the eval has very few components, which is good because it's like a super small chip. It does not come in the format of the step stick, which is like the Polulu 20 by 20 millimeter or something. And the reason for that is that it requires a bit more board in order to have enough cooling, because the MOSFETs are inside the package or the chip. So let's check out the specs here. So it's up to 47 volts, 1.4 amps. However, if you're running this on 1.4 amps and 46 volts, it's going to be really, really hot. And there are all sorts of tricks that you can do to make this better, or which are in the design. And a few of them you can see right here. So this is the TMC51 eval. I was wondering if I can get like a bigger picture of it. No. So, but you notice that there's big connectors here that we're going to be using. There are separate encoder and ref pins, which is also the same that I had in the design. But there are 2 large capacitors, which is important for driving most CNC machines because they have rapid movements, which makes the driver consume a lot of power at short intervals. Also, it uses current sense resistors to control the current. So this means that it senses the current it uses and then just adjust the timing probably on the internal MOSFETs or something in order to lower the voltage, for example. And then that will bring or increase it, depending on which way you want to go. However, this dissipates or needs to dissipate a lot of heat. So if you run like 1.4 amps, there's probably like 1 or 2 watts that's dissipated through those sensor sisters, and we really would like to have them as big as possible. And on this small design, it's not, it's not easy to do that, or it does a lesser job. And after all, the cost of making like a normal TMC 5130 driver versus kind of the best, or the best without going like really crazy far, includes mainly using bigger components and using a few more components, and then have some optionally bigger capacitors and stuff like that. So I was thinking, because this was going to be assembled by JLC PCB or something like that, if the components that we are leaving out is part of the normal assembly service, the cost we're saving is something like $0.0075 or something, and the price of the components, which is extremely little. So why would we do that? Well, we want. So what I've done instead is that I've made it so it's easier to kind of stack them on top of each other in terms of the way they are designed, or at least this is what I'm going to try to achieve. And we're going to look into that more detailed. So let's, what's the best way to see this? So let's bring out the PCB. Let's just update it in case there's nothing here. Okay, so everything is updated now. So as you see, there are 4 FPC connectors now. One of the FPC connectors is for 5 volts, cable select 1, 2, 3, 4, 5, 6, and a double ground. And there are 2 of each, because they are going to sit one on the top side and one on the bottom side of the board. So if you're going to use this as a single drive, you don't need all of this stuff. Also, I have a dip switch here, like a 6-point dip switch. And that is because you will have the option of, let's see, the dip switch is here. So you will be having the option to change the I/O for the cable select. See, here it is. And why is that good? Well, if you want to stack the drivers on top of each other, you need to have different cable select signals going from the microcontroller to all of the boards. And with this one, you can add 6 of them on top of each other, which probably will make for a hefty tower. Also, I'm going to place most of the components on the other side. However, this will mean in practice that when you order the board from JLC PCB, they will obviously not do the through-hole components. I'm not sure if they even do that, but they might. And then when you get the drive home, you can quite easily add on the stuff that you want. If your driver doesn't need a lot of power, then you don't have to put on the large electrolytes, if that's what we're going to end up using. Also, something else that we have added is these Schottky diodes, which are for are in conjunction with the stepper motors. So let's go out and check that out in the datasheet. Okay, now that I have this page open, also some other thing which I have done is that I want to be able to run this driver on full, highest voltage possible, which is I think 46 volts. And it has like an internal regulator, and if it's going to supply 5 volts to itself from a 46 volt supply, that's going to be a lot of heat dissipated just for the regulator, and this is really not smart. So I'm doing this design, which you can see on this right side here. So the 5 volt out is basically decoupled through this 4.7 capacitor, and then there's a 5+ supply that goes straight into the VCC, and it's going to go through a 3.3 volt regulator, which is the one we're going to be using also at the microcontroller board. And it goes straight into VCIO. And because of that, we don't need to have this major and the heat dissipation through the chip. We want to use heat dissipation for running and running the drive. So, because at least I'm going to run most of my projects with belts and plastic parts and casings and everything plastic, which most of the stuff is, right? So there are several ways of enhancing the circuit for ESD. So if you have static electricity built up because of plastic parts and belts and stuff like that, then this could actually discharge and cause major issues with your drive. So let's see. So there are several ways of doing this. So one, like the very simplest thing you can do is to add the 100 nanofarad capacitors to the sensor scissors. And you can also add the 470 picofarad capacitors to the like decoupling the motor phases. However, we don't have that because JLC PCB can't supply that. So we have not added that. However, we might still do that, but we're going to have to see if these parts are able as an external part. That's going to cost like $12, but you know, if it's in the design and there are room for it, then why not? So the most crazy way you could do with ESD protection here is to add varistors and you know, even more parts. We're not going to do that because that's just way more than I think we need. But you know, maybe we can change that later. But for now, we're not. So we are also adding this feature: reduction of resistive losses by adding Schottky diodes. Schottky diodes can be added to the circuit to reduce drive power dissipation when driving high motor currents. The Schottky diodes have a conduction voltage of about 0.5 and will take over more than half of the motor current during the negative halfway of output in a slow decay and a fast decay phase. So what's going to happen is that when we slow the motor down, it's going to produce and work as a generator and generate power into the chip. And instead of dissipating that power through the chip, we could dissipate a lot of that power through these large Schottky diodes. However, the Schottky diodes need to be at a rating which can withstand the voltage of the drivers. So they need to be pretty big, at least in order for use the ones that is used in with the JLC PCB pre-assembled service. So these are also added. Let's see, did we add something else here? Let's close this Macadunio thing. Okay, yeah, so I've added a few large electrolytes. I'm not sure if I'm going to use that. Maybe we're going to use like a bunch of the small ones, the small capacitors. So if you look at drone controllers, for example, like these really tiny drone controllers, some of them are like totally bombed out with capacitors or a small one. And obviously this is like one of the reasons is like there are a small form factor, obviously, in terms of larger, bulkier stuff, but also it's probably because of the when these are produced in China, it's a lot cheaper to just use 10 microfarad small capacitors than to use one large one. And you also would get like a benefit of better how should I say, heat distribution in everything when you have several of one thing, and it also will be a lot faster in terms of being charged and discharged. So we might look into that. So I've added the large format sensor resistors, and I have also changed out the connector for pluggable one for the stepper motor. I have also added TVS diodes for EST production. Yeah, let's go and check that out. TVS. Okay. This search is really weird. It breaks apart the word TVS. Okay, I need to put it in like, okay, this is really not great. Okay. However, we can actually see this in the eval kit because they have used it here. Let's see if I can bring that up. Jamie, could you pull that up? Yeah, I don't have it, Jamie. Let's see here if I can find the eval layout data. Let's see here. Okay, there it is. Let's bring it in here. So this is from the eval kit. Okay, this is for the reference point or the ohmic switches. Let's see here. Yeah, so there's a TVS diode here. And there is one for, let's see, where did it go? In conjunction with the encoder. Okay, let's try to zoom. It's not possible now. Okay. Yeah, here. See, you see it. Oops, here. Because like the encoder will be sitting on top of the motor usually, or it could be attached with like a belt. And yeah, it can also build up a lot of static electricity. And instead of having troubles with that, we could add the same TVS diode package here, and we can do it the same way. So I basically done the same that they have in this design. This is not mentioned, at least I didn't find it in the schematic for, not schematic, the data sheet for the TMC chip. But anyways, I will just I've added it. Okay, so is there anything else that needs mentioning? No, there isn't. Yeah, I also added like a rather large diode for reverse polarity protection. So I will try to get all of the S&D components except for the sensor resistors on the bottom of the board. And then we can actually just draw that in already. So let's go to the top silk layer, and we are going to Okay, let's get some proper snapping here. So 10 millimeter. And actually, now I need it to be 5, actually, in order to do this. So here, I'm going to add a placeholder for, so did we end up doing this right way? Actually, no. It needs to be bigger. It is that big, actually. Holy moly. Guess what this is? Well, this is... oh, that was terrible. Let's try to do it one more time. Here. This is a heatsink. So, okay, so we see this is 30 by 30. We are probably not going to use one which is that big. It's actually going to be 28. But let's just do 15, because then it would be a lot easier to kind of get it where it should be. At least this is what we'll try to fit on there. We see that it's going actually to crash a bit with these pins here, but we should also be able to move these a bit longer to the side. We could barely fit these here, these connectors. So we need to see if it's actually possible to even do this. So let's just add a line to the document here, like this, and then we are going to move this all the way to here to make it like very like the maximum to one of the sides here. Okay, because we need to fit this right here, line right. And now if this one, I can just hit this, and this, and if I now do distribute, it should add the distribute horizontally. Yeah, there. That should work. However, these should be actually everything. If I need to change the snap now, so I'll just do 0.1 millimeter. It needs to be just like this. However, the pins really can't be touching on the outside. So I actually have one of these laying here. So just need to control check that these measurements are the same, because we don't want the yeah, actually this works fine. There, the connectors is not longer than this plastic part here. So let's do this again. Right line. Line right. And now we're going to add, we're going to bottom align this. So they will be at the very edge of the board. Okay, that didn't work. I think I had, yeah, I had the line that I made there as well. So that made it go way past the board. Okay, there. Now I can lock this, and this should, should be good, or should work. This should work. Now let me lock this. And now you see there's actually space for this. Okay, so what should we do next? So another thing which I am not 100% sure how it's going to be at the moment is I have not made a microcontroller board. And I want to have one of these on the top side and another one at the bottom side. So I'm not going to add anything more here. So I was really hoping that it would be possible to have this heatsink, but also have space for capacitors. But it doesn't look great. This heatsink was a bit bigger than I was hoping for. So let's just try to change the heatsink to 14. And then we can also look at a bit smaller heatsinks to see if that helps. Oh, what happened here? There's something. So this is not okay. Yeah, I should really make this as size 14. Yeah, that's gonna do it. Back to the top silk. Now I should be able to just do this here and there. Okay, so there is definitely not room for capacitors on that side. So this is a 1 microfarad capacitor, and like I was talking, so they mentioned that you should have 100, or it's recommended to have 100 microfarad at minimum. So, and the tests that I've seen on drone controllers, for example, is that the more the capacitance you add to the better the signal, like the source voltage, is going to be, and it's generally not really expensive stuff. So we should just add whatever we need. However, then we actually need to have these capacitors or the electrolytes on the other side. That is going to be a problem, and I'm going to tell you why. So first of all, let's move this to the bottom layer, and maybe we can just see that for ourselves. So let's go to the 3D viewer now. So when you see, if there's like a big that sticks out on the bottom, that is going to cause a problem in terms of the stacking height, right? So and we can't exactly just stack it on top here either, because it's going to hit the heatsink on the other side. So what could we do about that? Well, obviously one thing is that we could go for SMD capacitors and just basically add more of them. However, we cannot add components to this side when when we design it with the JLC PCB circuits, because they only have single-sided mounts. So how should that be solved? Because I really would like to have people, well, actually, because of the sense resistors, people won't be able to use these without soldering, which is too bad, because it would have been great if you could just get them and it would just work, at least for some setting. Okay, we'll just make other drivers for that, I presume. I'm actually planning to make some very small format drivers. So I'm going to make a driver. I will probably do this after this, which will consist of a TMC5209, which is like the one used in those 3D printers or new ones, and just add a UART chip to it, like UART to USB, because I can, or at least I need to try it first. I think I can use the I/O pins on the CP2104 UART USB chip to drive direction and the stepper pulses. And I can read the data with, or the diagnostic data from the chip with the UART. And that would make like a super, super small drive. And I'm thinking of using that for like controlling lenses on cameras and stuff like that. So you basically input like a USB connector and it uses that for everything. And we can add like a nice small heatsink to it, or we could add heatsinks to like the entire backside. And it could actually pull some proper current probably with it, even though it is small. But it's nice to have something which is really small. Because if you're going to control camera lenses, zoom, and stuff like that, we really would like this to be, as small as possible. So something I really would like to make for my cameras and probably other cameras is some like a very simple way of running distance focus. Because if you're shooting with like a lens, like a bokeh style lens, which is you see the person, like, yeah, I can probably just show you this. So if you would just watch behind me, so like everything is a bit cloudy. That's kind of what you call the bokeh effect. And it means that the working distance of the lens is not great. It means that, well, it is great because that's what you strive for when you use it for making videos like this, and it adds like what people call like a cinematic look, and that is probably just because this is only possible to do with like expensive lenses. However, if you were in the microscope business, this would be like bad, and because when you use a microscope lens, you really would like to have as much both working distance and also how much of the depth, how much of the have like a high depth of field. That means that there's a lot of stuff you can see which aren't actually in focus, right? So for normal, like your cell phone camera, it could have both my face in focus, but also the background. But in order to have this nice, cool effect that people like on videos, you should have like the background blurred and people like really clear. And this is quite hard because like if I move a bit now, if I don't have automatic focus or phase focus, it would be really cool to have like a time of flight sensor, like this small laser on your lens. So it kind of keeps you in focus and it's not even controlled by the camera itself. It just turns the lens manually. And by doing this, you can have like super fast automatic focus. And you can also use like really old lenses, which can give super great lighting and color, but they're usually useless because they really need some really heavy autofocus stuff to work. And old lenses don't wear well with like the they can't be controlled by modern SLR cameras and stuff like that. So we can just do it manually by creating something like this. Okay, so that was a small tangent. Let's not go too far on that. So back to this design. Yeah, you can also see that the sensor resistors here are a bit larger. I've also added additional tantalum capacitor, like a 10 microfarad one for the power supply, like the 5 volts, because that is going to run the chip. And if you have 6 boards stacked on top of each other, long cables, we don't want to have problems with that. And these are quite easy to solder also by hand. So yeah, back to our capacitance challenge. So let's go back to the PCB here. Let's just try. First of all, let's just decide what components are going to be on one side and what is going to be on the other side. Okay, I need to change the snap back here again. We'll change it to a millimeter. So this is the cable select thing. Okay, so this is like one of them. Okay, it looks like snap did not want to change. Okay, so okay, let's first let me just check the chat here to see if there's like no one there, no one there yet, but that's fine. Okay, so these are going to be on the top side. This one is on the top side. All of this is going to be on the other side, and I might need to lose these capacitors, or I'm not quite sure where to actually put them. They could be put in on both. Well, no, actually, they need to be on the top side. So let's move these over here, and we'll see what there will be space for, basically. So first of all, let's just change all of these components to be on the bottom layer. There, and now let's just save. And then let's just grab all of the other stuff that here, like these small components that are already there, can just stay there because they should be in the right place at the moment. So the chip is the thing that is going to be driving most of the heat. However, it might be that we should have it a bit further down. Let's see if the chip is centered. Yes, it is. Okay. So, yeah, it is the same. So now let's get the big sense resistors. Like when I said sense resistors, I feel like I'm saying sisters for some reason. Okay, so I can have these on either sides, or I can have one that go on each side. So I can have one that will go from here, from the center, or from below here, and then one from the opposite side like this. So what I'll try to do is, yeah, exactly this. So I have measured how much angle I need on the cable in order to make it bend. So should I have it at the center, or should I not? I'm really not sure. We won't know for sure until we have also made the other board like this, like the microcontroller board. We'll just put this here for now. So these Schottky diodes are not going to be soldered. Actually, they are. I think they are. Like, yes, they can be placed. So they should be on the backside. Okay, let's get the sense. Okay, these are quite easy to put here. The sense resistors. Let's just have a look at this pop group of sisters. Sensor sisters. So they should be as close as possible. Okay, I'm gonna do the snap to 0.1 now, and C16. So there it is. Yeah, I haven't added net names for these, and I should. Well, that might trigger actually like a issue, I think. Let's just try to see if it's possible. There, I even changed the color. Okay, oh, bump them right here. This is the BRA. Just really don't like to have. So let's see if this is going to work. Yeah, it worked. It used to give like a DRC error because it was like only one name. Let's see, it seems to be stuck at 0% now. Okay, let's abort this. Let's go and save the PCB in case everything will crash. Yeah, I don't want to do that check now. I saved, let's try it. Okay, let's just wait for a few seconds at least for it to run the design rule checking. Yeah, there seemed to be an issue with this. Okay, let's just update the PCB. So we will get the proper names here. Yes, BRA. So yeah, sensor sisters, important. So, but also this filter capacitor. So we can bring them like really close like this. But as I talked about yesterday, they should not be so close that okay, let's do 8.5 and -4. There. And they should also be similar place to each other. So like you shouldn't have one like this, because then you might have some issues with the different faces. So it was -8.5 and -4. Okay. Let's see if we can. Oh yeah, we need the encoders there now. So because I'm planning to just run the. Yeah, maybe that's not a good idea. I was thinking just to run these through. So actually, let's rotate these. And instead of putting it at, probably not a good idea to run the main power beneath this track here. So let's see if we put it at -6. Okay, -8. Do we manage to skip these? Yeah, we do. Okay, let's try to have them right there. The most important thing is that they are, well, they're close, but they also have this kind of same symmetrical design. I really not am happy with all these names popping up. Like they're probably helpful for something, but okay, so that's taken care of. Now, what about these big Schottky diodes? So they go one to each it is, and then to the sensor resistors. So these are, at least just move them over to the side that they belong to. There, move the designator name or whatever it is called. There, okay. So they should be switched. So could we have them like this? So remember, this yellow line here is not necessarily for it's for the top board, and it won't affect the bottom one that we are actually routing right now. And there. So this is going to haunt us when we're going to run power tracks, I think. We'll see. And we should also have added some extra capacitors. Are they up here? Yeah, 10 picofarad. 10, 10. 10 picofarad. So that's the same as 100 nanofarad? Guess so. Well, actually doesn't matter that much at this stage, because right now we just want to place the footprints for them. So what the heck? No, these are for the encoder? Oh yeah, it was actually one of them there. This was weird. It never paired like they were together, but they were not, because here, no, these are not the right ones. Where are the others then? Okay, there's one. Yeah, there should be only two, one for each sensor resistor. It's quite easy also to, when you are putting components on top of each other, to suddenly move something which are at the top. Okay, let's put these here for now. And this is at, so minus 12 and minus 8. 12, minus 8. There. Okay, and what's the other stuff that we have here? So this is the, yeah, for the reference pins. There should be one more. Let's do them first here. Another one. These can actually be placed even here on the bottom side of them. Well, at least we'll do that for now. Because weird from now, but if you see here, it's like, oh, they're gone, but they're not because they're here. There it is. And what we're going to do as well is like expose this large area here with the copper, so we get maximum heat transfer into the heat. Like I can't even speak now, into the heatsink. So this is cable select R11. Yeah, I should actually have spent time renaming all of the components now to have them have proper names. Oh, look like something. Okay, so yeah, so this is like a 0 ohm resistor. This should also be a part of the bottom design. So this is going to be placed at the same place where this here is going to be placed. Oh, that's really, really close, but it's possible. The reason for that is that when you get this board pre-assembled, it will have the 0 ohm resistor on it because it's going to be using the default cable select, right? However, if you want to stack multiple boards together, you'll just solder on this dip switch right here because you can't use this dip switch with the assembly source. We might change to a pinhole version because it's going to be easier to solder. But for now, we're just going to have this. But I'll also be just moving this to the outside here because I'm not sure where exactly we're going to put it. So what's left here now? So these are the 4.7 K resistors. So these all belong to the encoder. I honestly don't know why the encoders need this voltage divider circuit. I guess it has something to do with the Trinamic. Encoder. They're running on 5 volts. Yeah, actually, let's just have a chat. No, have a look again here. So this is the I/O. I'm not sure. Let's see if I've done this right. Yep, it says VCC I/O. But it's VCC I/O 5 volts or 3 volts here. So like, why would it need 5 volt and then also need... Oh, it's pull-ups. Okay. But however, I think that you can both have 3.3 volt. Yeah, it is 3.3 here. This is the I/O is 3.3. Okay, so it should be right because it's the same. Back to the PCB. Now, where should we add this here? Well, we could use the same kind of logic to put it here. So it could make some sense to actually have these resistors and that stuff here because we won't be running big power cables here. Well, there will be power running above it, but it won't be inside the circuit board. So we could actually place a lot of this stuff here. And that should be fine. So let's bring all of the stuff here. There's a lot of components which is needed for this encoder. This sucks. So we could be getting like the VCC IO from over here. Let's have a look at the encoder cables. Ground is everywhere here because I'm going to use ground planes. So that should be easy accessible. Okay, let's try this. This is the capacitor. Bring out the another resistor. Resistor. And I think there's the one missing. Should be 6. So this one is at 4.7K. This is the 1K. Okay, so we'll add 1 to the other side. This is for E. This is the 1K, is it? Yep. Okay, we'll put that on the other side. So let's remove this for now. So this one goes straight into here, and let's not put it too close. Oh, this one actually goes to the input signal there. Okay. Just try this for now. These are the 1K resistors. There. Another one there. Let's center it. And then is this a 1K? No, 4.7K. 1K. Yeah. There. That should be all the way over here. It really feels weird to put this on top of each other because let's just remove the top silk screen. What's this? This is on the top layer? Oh, let's bring it back. There it is. Good thing I tried that then. So this is the 4.7 resistor. Sister. Okay, so let's try something else. We'll rotate this here, and then we'll add this here, like this, and then the ENCA. So this one goes. No, these need to change place there. So there's one to each of the encoder signal pins. There. And then yeah, I guess it's not possible to do it like that. Or let's try this. Select both of these. They're the two resistors. Rotate it like this. There. Actually, it needs to be more like this. The same with this thing. Oh, this was the wrong one. It's this one. So I want to try to not cross. Okay, there. Let's bring it a bit more over to this side here. Yeah, I'll save the rest for this until the routing. And then you have the capacitors. These can also be placed, obviously, somewhere else. I'm not sure where they are best suited. I need to read up on that. Let's pretend that, okay, we'll just put it here like this. I need to read up on it. There. Oh, yeah, and then obviously TVS diode. Where should that go? So it needs to have one into each of these. No, these go straight to the encoder here. So these can actually be on this side, like this. Okay, we'll just save it there. And these are the capacitors, or some of them. So this one can go here. Oh, actually it can't, because we are supposed to be able to have many of these next to each other. Yeah, I don't need to do that. I just need one in the corner for now. I'll add the rest later. Actually, I need to, I need a footprint for it, so I probably should just add more. Even though they are, yeah, it's gonna mess up this, but like, who cares? So, oh yeah, this is the motor connector. That's not the one. There's the main power. And I need that. And it's a bit different now. I think I need to rotate it like this. Then I'll copy 2 more. Just do this here. And now I need to move this to the side, just like this. And I'll remove this joint here. Move the names to the other side. And there. And now I can add these other. connections. Just need to make sure that I don't accidentally attach them to the VS here. If that would have happened, I would have gotten like this junction point here. Okay, there they are. Now let's update the PCB. And we'll be getting a few more. Now let's just come all the way up here. And then we will put, yeah, they don't need more space between each other. Yeah, maybe I can use that extra space. I'm not sure if this footprint is exactly right. We'll see. And, you know, you will be not connecting all of these, or you can if you want to, but you don't need to. Seems like it makes sense to flip these. Yeah, the ground should be the square one. Let's go back to there. Now I'm going to do flip vertical. Oh, that was not the right thing. Flip vertical. I guess it's sample. So I can never learn this. There. Update the design. Now we should have it the way it should be. Yep, that's better. I'm thinking to put this all the way up here, actually. Why is this line here? Oh yeah, I think it's because of these here. Let's see. We'll see. Because I want to use all this area back here for capacitance. Let's rotate these to be same positions. Well, that one was already rotated. Why did I change that? Okay. Let's select all of them and do format line bottom. And we'll just move all of them up here. So we'll add one here and the other one here. So let's see how much space we get between them here now. It's there's probably too much to add 100 of them. Let's see. Distribute horizontally. Okay, so yeah, they could be closer. So let's remove this yellow line and hope that it wasn't for something really important or no. Okay, let's bring over these large capacitors. They could be here. Actually, there could actually be a room for two, like more of these here. I could also add like a large ceramic capacitor. Obviously, you can also use smaller capacitors. So I can actually get more capacitors here, like if I want more. Well, but maybe I can't because I haven't even placed the dip switch. I need to place, okay, but these can obviously go all the way up here. So probably not. So how big are these? Yeah, these are 100 each. So yeah, this should work just fine. So let's put that at -19, and then 15. I just like to have these as like nice round numbers in case, will be pick and placed. And this was too close. No. Yeah, this looks weird, but it's just that they're on top of each other, but they are on different layers. Looks a bit messy. So there. Now let's just go over here and see if these are the same ones. Because we can just add VS on the. Okay, this is the cable select one. I probably need to flip like one of these. I'm not going to do that right now because I'm not sure what the best orientation for them actually is at the moment. Now I just need to see how everything looks and then see if it's actually possible to have it this way. Okay, so yeah, there is room for this right about here, and the tantalum could fit here. Oh, now it's the only thing which is left. No, this is actually the tantalum. That one is the cable select one. You see here that, yeah, I have this all the way down here. So we're going to remove this one. And this is the IO. Have I switched that around now? No, I haven't. Yeah, this one should be actually at the other side. This belongs here, as you see it. This one belongs here. Bring that all the way on top there. And collect the... Yeah, this was the resistor. We should have... Yeah, it could be there. Yeah, I remember now. This should supposedly be like this. Let's leave it like this for now, even though it's going to look a bit weird. Oh yeah, this is going to be on the bottom. And it is. Okay, so let's check out how the board looks now and see if there's like some major issues that will cause problems for us. Okay, so it looks decent. There seems to be some problem here with this capacitor here. This could be placed a bit different. Could also select another solution for this. Looked rather cramped up. Let's move it a bit. Yeah, I'm just such a devil for this symmetry thing. But it's gonna sit inside something. And it's like, well, only one side. So here is one side, right? Looks fairly decent, right? Yeah. This should be centered over these. Or should they? Not sure. Because this connector is not at the center, which is not, not great, but that's how it is sometimes. If I want to add like a border here, I need to also fix this. But as you see here, there's like a lot of more space closer to this. There's also a lot of space here and here, which I can actually have a lot of this stuff here as well. But I'm not sure where it's, serves its best purpose. So let's flip this. So obviously the drive would work with everything except for these here as well. I can also add capacitors, the possibility to add capacitors here. If you want to do that, like these large ones. If you don't want to use these. Let's change the black. Yeah, so yeah, this is how it could be. Obviously, it would be somewhat annoying to, yeah, maybe you can see this switch from the side, but you're not going to do this. You're going to do it when you set it up, and that's it. And you can look at it when you stack them together, or it should be quite easily. But however, it might be that it will be. It's like it's supposed. So it's at like a potential thing that could go wrong because it's SMD, and when you push it all the time, but should be quite easy to do. Yeah, so I think that we can now try to start the routing and see where that takes us. But first, I'm just gonna have like a really small bathroom break. Okay, so we're back. Almost. I'm almost back. Need to plug my charger in. My phone is running out of power, which is not good. Okay, good. Let's see if the streaming gear is still working. Everything looks good. Yep, it's fine. Okay. Yeah, there will be 3 holes here. So I should move these FBC connectors up a bit. So I won't spend too much time completely routing, everything here. So I need to have, let's do -7. See if this is still gonna work. Yeah, it already is at 7. Okay, good. Like something I'm not sure. So these should actually be as close as here as possible. -7 and -18. Oh yeah. -7. Did that work? Yep. So sometimes these connectors, when you have them on opposite side, they don't match up because the center point on the component are not matched. But these seem to be right. Sometimes I really recommend to place these stuff here first because maybe you do some really advanced routing and then you need to move this stuff and you forgot about it. That could be like an issue. Locked? Yes. Okay, so where do we start? Well, one of the most important things here are obviously the big power signals. So you see here that we'll be having high-speed signaling going in and out here. So that will be running right under the big power tracks. Yeah. You hear all these kinds of horror stories of, the SPI stuff should be like this and that. And, if you really try to make it bad, it still usually works. It really depends on the speed. But the speed set we're talking about for this is really, really not. It's really not as important in order to, just get something decent to work. If you make like a proper product which you're going to sell, that will be misused and put in all kinds of ways as well. And you will have the responsibility for it for 10 years. You could invest more time in getting things right. But like today, this board doesn't exist. Well, you can buy the eval kit though, which costs a lot. I'm not sure how much this board is going to cost. I hope that it will cost, let's say, sub $30. We'll see. Okay, let's just try to run some routing here. So we'll do this one just straight out like this. We could have placed it actually even closer, but I'm a bit afraid of when this is soldered manually to, for it to be too close here. So we are also going to make this wider, like a wider track that will be on top. And it quite could be hard to fit one because because this has like automatic. See, no, this is actually going to work fine. So that works. And you really want this to be teardrop shaped. At least that's what I heard. Well, it's like all about, when you're going to make copper, you really would like to have nice rounded drop shape, drop shaped, and you really would not like to have a 90-degree corner. Okay, that looks fine. And now let's run a 0.3 here. I'll just do it like that. And this one. All the way out there. Now let's see how much we need in order to make 2 vias here. Yeah, this is going to work. Yeah, I have some snapping issues here. We'll just turn snapping to 0.01, and then we'll just realign stuff later to make things symmetrical. There, and the other one, let's go straight out like this. And we add a couple of vias. We could even add 3, but we need at least 2. Or, so we could use 3 like this. If I make the via here, it's going to have OB2. If I place it here, it's not going to have OB2, but that's fine. We could just manually add it. And now I can obviously add the copper track here. And we should really fill this part here up. It has some issues sometimes. Also copy it, which is better because then it inherits the via or the net name. And there, should add a bit more copper around this. Let's select these, and yeah, now we have width. Let's do, what happens if we do 6? Yep, still won't work. Copy another one there. Let's also check out if they do this in the eval kit. Right? They did this in the non-eval kit. Yeah, I wasn't supposed to do that. I wanted to do this. Add 2 vias. 1, 2, and then we'll copy 1. Is that 0.6? Yeah, it is. There. Is that the same? Nope, it's not. Because this is still 0.3. 0.6. That worked for one. 0.6. Doesn't want to change. 0.6. That worked. Okay, now let's look at the eval kit. And see if, so I guess the PCB is not here. No, it's not. But it is in, it's in the data sheet. Here. So let's see. Yeah, so they used to do VS here, one there, one there, one there, one there, one there, one there. And then the sensor sisters, it just goes straight out there. Sensor sisters. Yeah, it also has like these VS around here for heat distribution and for grounding it to the ground layer, which we will do as well. We can add it also to the inside. We'll see. Okay, so now let's so we will be running quite thick, like 3 millimeters, something like that, up here to this one. There. Yeah. This is as thick as it gets. There. Oh my God. There. Okay. Now, we need to do a change here. We need to change the board into a four layer one. For some reason, I haven't done that. Design. Where do we do that? Tools. Layer manager. There it is. So let's add copper layer 4. And yeah, this sucks. And then hit settings. Okay. Well, I guess that's how we confirm it. So then we'll add on the inner 1, it will be. Because inner 2 will be total ground thing here. Okay, so we will be routing this now. Yeah, so obviously let's route it from here. Yeah, I guess we need to. Have it something like this. And we might even change to even thicker tracks here. If that is possible. And it is. 3.1 works. 3.2 Oh my God. It thinks it's like a password field. 3.3 works. 3.4 works. 3.6. Yeah, that's probably a bit too little. Well, oh yeah. It's like, why is this? Yeah, but this can obviously be moved out here. I guess I'll have to move that as well. Okay, that's one. Let's add another one up here. So it turns to the side here and goes up here. Okay, and now it's this one. What? We actually... Oh yeah, I think I remember. They're kind of flipped. I remember this from another drive I was creating. So it's not ideal. The reason for that is that we would like to have VS here, right? And then we will be adding those here VS straight through the power plane, which is not a good thing. So we actually, and these should also be as similar as possible. Yeah, so I guess, well, it's not doable to do it another way. The problem is that when we run the VS for this power plant, that's not good. I guess. How do they fix this? Let's look at the design. Yeah, we can see it here. Let's, we need to open the package Altium PCB viewer. Let's see if we can open this the same way. Well, I guess this didn't work. We only have the schematic, and there's not a picture of it. Okay, let's try the layout data. Yeah, that didn't work. But there are PDFs here. Let's open them up one by one. Inner 1, top, inner 2, and bottom. So, why can't I zoom? I don't want automatic zoom. Now, how do I scroll this? There, yeah, so the center one goes on this very side there. Can we do the same? Yeah, we kind of have. So we can, if we pull this like that, and if we would move these, we can move this a bit. That should be fine. Let's go to this layer. Yeah, that should work. And we can also move this all the way up there, and then we can stretch these a bit more out here. Yeah, we can redo this afterwards. And we could run this trace here. Then, yeah, we could obviously use like a lesser width there. Let's see how they're done it. So these tracks are, yeah, let's see how small or big they are. So they are, yeah, they're approximately the same. Let's open the top layer. So how long out? Yeah, they have the sense resistors a lot further out. And this one starts right there. Okay. We could also pull the sense resistors further out. So that means X should be, let's try 10. I guess that's too much. 9.5. Work. Minus 9.5. Now, we can pull this over here like this, and this further down like that. Now we can pull these further here, but we should do the same with these. Well, actually, we don't need to. We can do a bit longer out. But we'll try not to do too much, because these will be, should have the same length, especially where they are really close to each other. Let's just remove this one and just remake it. Inner one. Okay, that's better. But I guess we could also move this to the side like that. Yeah, we're gonna have some issues with the there. Let's match it and see if we can. Okay, yeah, there's going to be, this needs to be lifted up here. Yeah, I'll remake this. And then we'll just slide it to the side. Okay, almost. It wants to be dragged to that center position. Okay, fine. Now let's move this even more. Okay, we are almost off the chip now. There. OA1. Okay, it must have snapped a bit now. Okay, the snapping is because this needs to go all the way up here. And now if I pull it, okay, so let's bring this down to 3.5. Okay, that helped in terms of will be good with 3.4. So we could pull this, make this a little bit smaller. Yeah, we'll fix that in post. Okay, there's some fat tracks here. Okay. We might need some better isolation between this, like having move this a tad to the side. Add some more distance like that. There. How long is this track now? Yeah, it doesn't say. So this one is 4.23. This is 20, 17, 19. And how does these look? Are they the same length? Nope, they're not. But they're probably within what's possible. So why does this give an error? Oh yeah, we haven't done the change to this one here. Yeah, I understand that this is an issue. Let's reroute these. There. Does it need? Okay, I need to move this a bit. Maybe that helps. Come on, come on, come on. Nope. It says nope. Well, these are probably like just like when routing this big tracks here. It's like, so now I can push it and I can just start to. Obviously, it can't hit that part, right? So, see, but there's like a place here where it actually works. If I just go up, up. Okay, that works. We have some fat traces now. Let's look at them. There they are. Should probably move this closer. Why is it up? Oh yeah, it's that one that we had to move, of course. We can move this though, so it will be a bit fatter like that. This could be, yeah, this is 1. We'll drop this to 0.8. And we can have this one here to be 0.8 as well. Yeah, just slide it there. Okay, so now we have routed the main power to the motor. Now, the other kinds of power, and that is power to the chip itself. We obviously need to do that on the bottom layer. So before we do that, just let's have a look here, because that is going to take out a lot of the access to this stuff here. Because we need to come in here on the other layer, which is this one. Yeah, we'll be moving on more of the stuff. So these are the the 100 nanofarad caps, right? Yep. So these should be close. Is this 100 nanofarad one? Is there 3? Why is it 3? So let's go check that out. So there's one here and there. Where did the other one come from? That's probably going to sit somewhere else. This is 100. Yeah, this is actually not needed because it's already there. It's just an error, my mistake. Update. Apply changes. So there should be one on each side here. So if we should be running some big power plants, we could have this here, something like that. First, let's add the small ones, the really small tracks. Something which I always wonder is that I guess that these tracks are so small, so it won't matter that much, that. But just think about that. You pull these kinds of amps out of these really small traces here. It's mind-boggling. Okay, let's have it there. That's minus 1.5 and 7.5. Yep. Now, minus 7.5, minus 1.5. There. It's a better idea to have them at minus 1.6, I think. Or maybe even more. Minus 1.7. Maybe minus 1.9. Minus 1.9. There. So let's see if we can route some fat traces down here. So how should we do this? Well, I think we'll just start almost free-handing this stuff here. 3.6 or something like the biggest. Actually, we'll just start with one side. So it would be nice if this could come like oh, I can't drag it. I need to slide it and change the snap, or else I will be sliding it forever. Something like this here. And then we'll change the net name to yes. Yes, haha. There, and then we can copy it. And we will flip it horizontal. Because then we can move it and it will be symmetrical. Just almost. So it needs to go a bit further out, not a bit, but a lot. There. And obviously this needs to go to 9 minus 9. So 9. We could change this maybe to be 0.8 something. Ah, yeah. Add that. Now I wasn't trying to free this. And then 0.8. See if that's possible. Yeah. And then we'll add an angle to this and just drop it straight in there. Okay, that's nice. Just copy this one over here and we'll just drag it all the way down there. Yeah, that seemed to work. And zero point 0.3, both RVS. Yeah, we'll fix that later. We'll fix it in post. Okay, let's have a look. I'm not sure I want to look, but it's like, yeah, okay. So now we need to make some choices if you want to continue with this, or actually not. Because I'm thinking about the capacitors, like how we should do this. So how much capacitance does we have from this? I have 1, 2, 3, 4, 5, 6, 7, 8. And these are placeable by JLC PCB, right? So I should actually just have maximum, just a maximum amount here. And how much would that be? Adding 2 more, that would make it 10. Let's add 2 more. The prices of these are like nothing. And let's move them to the bottom layer. Remove that. Oops. That name. Flippity flop. See, that will fill it out, I guess. And then we'll just reselect all of them like that. And I'll do align bottom and distribute horizontally. Yep. Still room for it. And now I just need to take a very short break to do a phone call. But I'll just continue with the video. And we're back. So I'll just start to run these here. Yeah, this is the VCP. This can be moved over here, probably. Down here and through this here. We'll try to have some distance. Up you go. Oh, that's like the ground. But we'll run this ground straight in here like that. Unless we need to, yeah, do something else there. VS. Why does it complain about VS? Yeah, they're not connected together. Like, I could do this just to make it to shut up. But I'm definitely not going to have it like that. Or am I? Just want to remove the small little line there, like the rat line, it's called. VCC IO. Okay, it goes straight in there. And then we have these two buggers. How should we solve them? I don't think I know. Okay, it goes straight in there. But I'm also going to run all of this. And okay, so this is actually going to be sort of an issue. I think I need to move this one like this. I need to have room to put VS here because I need to dive in here and get past this stuff here. And I'll probably run this on the inside here on this layer, the inner one layer. It would be great to have like a separate signal layer, but you know, it's just not possible here. Well, no, it is not because of the diodes. Like, we could also, yeah, actually, that's, you know, it's not too bad. So if we, how should we run the bus? So the problem here now is that the only way we can actually run it is up here to this side, because we have blocked this with this layer. And I don't want to put like tracks and divide the ground layers. They should be pretty clean, especially close to here. I can obviously pull the entire ship up. So we'll make a bit more room. Maybe I need to do that. But you see, the problem here is that this is the motor current, or motor tracks, motor current, goes on inner one layer, and then we have the diodes. on the inner juice. Actually, I'm now realizing I'm doing something really stupid that I don't need. At least I think. So we could... If we move... That will make us redo most of the stuff here, actually. If I put the dial... But that's part of how this game is. So if I could run VS... Like, I don't have to have the dials here. They could be moved up here. And then I can just run VS straight into this place here. But then I would have to move all this stuff a bit up here. So that means I basically just need to remove all the stuff I've done. And I'm not even sure if it's gonna, like, yeah, but it's gonna be up here. Yeah, we might as well just go and do it. Let's just remove stuff now. All the nice tracks. Oops, let's not remove that. Yeah, we could actually remove all the copper in one go with like a global delete. That's necessary because we could at least keep some other stuff here that we will still reuse. Okay, so let's actually, no. Let's go and do like a global delete if I can find it. Global delete tracks. Boom. An hour. So, but that's just how it is. So we'll take this. We'll just move it upwards. Oh yeah, the sensor resistors. Oh, I can actually have it at the center now. Kind of cool. Let's try that first. Let's get the resistors, unlock them, and let's move this junk out of the way. Just put it up here. So is there a better way? Let's rethink this. So what if we do this up here like this? So this is, yeah, it's going to have some issue with that one. This can be moved up at least one bit here. It'll mess up the symmetry, but I gotta do what I gotta do. It's almost at 0 now. Okay, 11.2. Eleven point 11.6, 0.6, 0.6, 11.2. Okay, let's lock them. They're even now. No, they're not. X location, 11.6. There. Okay, lock. Okay, let's see if we can bring up these diodes here. So this goes to the top. I have routed this thing before, and I think I'm not sure how I placed it back then. Let's see. I might have done this like similar. And we need to flip this. We'll align it like this. And then move this and this one. And we flip this up here. Now this is 10 minus 10, 4, 10, 4, 6, and 4, 7, and 4.7. Okay. Other thing. And then let's move this up here. It only needs to be approximately at the moment. So we are going to get a bit more actually like the tracks here, but that's going to be minimum. And there will be a lot more place to run the speed and the stuff here. Okay, so now check this out. Let's yeah. No. I guess it's gonna be fine. Yeah, let's first. Oh, yeah, I guess that's a bit too skinny. 4. That's a bit too much. 3.6. Let's do 3.5. I think that will do. There. Now, yeah, there's also another thing we could do. No, we shouldn't. So what we want to have this space here open because we need to route stuff away from here. And that's like one of the reasons why we actually did this. First, let's just left align these. Align right, I mean, oh, why didn't I click the third one? Align right. I actually aligned the track, the copper track. That's what I was clicking. Align right. Okay, this one, align right as well. View, format, align left. There. Okay. Now let's go to inner 2. No, 1. Inner 1. And this needs to be something like this, right? And up here. There. And now it's this. And then we'll drag this down here. So we can also move it to the side. Like this. And then the other one. There. Oh, a phone call. We'll be back. And we're back. Okay, so we need OB in here. Nice fat. Oops. Yeah, I don't need this to be that big. Let's start from here with the 0.3 wire. Oops. 0.3 into OA1. And we'll just put it, let's just get it out here first. And then we'll just get this out. And this needs to go all the way up there. Yeah, so obviously now this will limit the trace going down here, and obviously that's going to be a problem with the VS here. So yeah, we already have an issue with this. Can we put this for, no, we cannot put it more to the side there. Yeah, maybe this wasn't such a good idea after all. Well, we'll see. So this could be traced up here. Let's make something 3.6 is obviously, yeah, that's a bit too much, I think. 2. That is also way too much. Okay, so let's rethink now. First of all, we have switched around these two. And what could we do? Okay, we could also replace the sensor resistors to be smaller. That will help a lot. We might need to do that, like back to 1206s. It looks like I need to round off the stream pretty fast because like my daughter is calling me every single minute. Hang on. Okay, we're back. So what to do? Bigger sense resistors, something else that I haven't thought about. Not bigger. I could also move this a bit out, but you know, there's like, yeah, that's gonna help. Maybe that'll do it. Let's just try. X location. It can be there. That will give me 2 more millimeter, so they can go to 13.6. I will get quite a longer trace out there. But, you know, maybe that's what it takes. At least this looks like it could work. Yeah, actually it will. Yes, I can actually. This needs to go in there. Why have I? Is this OA1? Yeah. This doesn't need to go up here at all. This could stop here, like this. And this also does not need to go so far up here. So maybe that there is the problem was because I had misplaced the Schottky diodes. Like, so it seemed to be a problem, but maybe it's not. Let's add some VS here. Oh, there's some snapping issues for sure. Oh, I just want. Oh, I do. Okay, thank you. Copy that. Yeah, we have some big snapping issues here now. So, okay, I'll just need to slide it down here like this. Up, and we'll add a third leg here. Maybe there. This can go straight into here. There, and yeah, that's a bit too big. So we're going to add 0.3 via. Yeah, should be 0.6. Okay, we'll do. Now we have some, yeah, control save usually removes a lot of that problems, or those problems. We'll fix this later so it's like more nice and rounded here. I just want to figure out if this is actually going to work or not. So here we'll do 3.6. And I'll just drag this down here like that. And I think this is locked here. So we need to overlay a bit here. And then we need to have the VS. So we need 3 of them. Yeah, so major snapping problems here. Like, I wish there was like a button that you could hit and it won't snap. It's like impossible to use it. It's broken. You need to slide it to the side. And one more. That's fine. Software is free. That's great things. So, okay. Now we could have a fat VS trace straight in there. We could also add this a bit much more to the side, right? And this can actually come back. Can't it? Yeah, we need to move this up here because obviously we have the bra. We have the bra here. Yeah, I guess it only wants to be big now. So let's try again. Okay, there, there, there. Left align. See what happens. Oh my god, this is locked. Format, align left. Yeah, we can fix this. And then we'll just do... Yeah, there's like the poor software has really big issues with these big tracks. Zero 0.3. Let's add 1.6. Yeah, that was a bit too much. 1.2. Just pull this up. Probably. Yeah, let's do a design check. I'm getting fed up of this, all this problems here. Okay, yeah, I know that's not going to be 0.3. Right into that sucker. Obviously, I can also do a bit like change this. It doesn't need to be the same triangular, but it's nice to have it, yeah, because this. Okay, so now it goes from here to there through these vias. This one needs to go all the way up there, and it obviously need to come up there to make a connection. And it should be up. One tick more there. It should be covered by the via. Okay, so the BRA. Yeah, and this needs to be, yeah, working with these big vias is not great. I usually have used like copper fields instead, but they don't give like nice rounded edges. But then I can have like maximum, like doesn't need to be symmetric like traces. Maybe I'll change that because this is really time consuming. All right. Probably best to drag it off somewhere else and then adjust it. Or do something like this. This is bra. Bruh. And then I need to slide it down like this. And I obviously need to remove this because now it's kind of touching the ground, which is not cool. There, that works. Okay, what happens if I... Okay, there you go. A lot of copper. I can move this. It'll actually look at it somewhere to the other thing, other side. Oh yeah. It's hard when you have to do stuff like symmetrical try, and it's like at this stage, we shouldn't care that much about it, because as you have seen before, we might need to change everything. Okay, let's do a 0.3 OB just straight in there. And then add some wires for this thing here, which is like freaking all over. Obviously, it can't cover. This is OB1. OB1, Kenobi. I'm gonna have a lot of fun with that. This doesn't need... Oh, come on. One, two, three. Where did the third go? It's probably beneath. Yeah, it was. And now this will go straight into the... Oh yeah, so we have the same issue with this here. How did we solve that here? Yeah, it was... We need a small out here, but the BRB... Let's add 3 vias here. That is 3. Okay, I'm gonna... Because it's like there, going badly. There, and then we... It's the effing track. I don't want to place it. Okay, so let's go to this. And this goes out there. And how? Yeah, it uses this big one for 1.2 millimeter. It's actually this one. We'll copy it. And 1.2. Need to change the angle a bit there. I can't drag it, and then, okay. Yeah, this is just way too close. Oh, I'm getting too frustrated. I should take a break. There. I should just redo everything and use like the copper planes like these here. Like I can do this, and then I can just drag them, fill out everything. And it doesn't give out nice round corners, but I might add that on top. Maybe. Okay, let's have a look. So now we can obviously add those fat VS tracks back here now. Yeah. We haven't connected OB2. Actually, OB2 needs to go here. Yeah. Oops. How did I do that here? Oh, I haven't traced it yet. Okay, so I'm going to take a break, and I'm going to actually redo it with these other types, because then I won't have this super annoying problem with this snapping of the tracks. This software doesn't work too. I might be something wrong I can do, or just be something else that I could do in order to prevent this nightmare snap thing. Yeah, but we'll see. And yeah, I guess it's going to work. Sometimes things just take a bit longer, and maybe if I quit now and I'll go back and I'll have like some other idea on how to solve it. I should put these back. I should put this back actually. Let's X18. So I won't forget, and then I'll fill out the space, and in order to change it, I need to change everything. Okay. I could also move it even further up. That will create even longer copper traces here. But, it's probably not going to be that big of a problem. Is there something else I could do? If I hadn't this, I could have moved these FPC connectors all the way up here. But then again, I also might need to move those. Okay, so we'll leave it at that for now, and I'll continue the routing. So let's just finish up by looking at this stuff here now. Oh yeah, I need to move this, because this is like inside there, so there's something wrong with the footprint, I guess. It's like wider. Yeah. I could also put smaller sense resistors, but I really would like to have this to be like a full power thing, so maybe not. So yeah, I guess that's it for now. Yeah, I'll catch you next time.